go to chapter 13 here, and we're going to look at blood vessels and circulation. So we had to compare veins to arteries. Arteries have a much smaller lumen. They have a much more muscle, smooth muscle around it. So since the high blood pressure leaving the heart goes through arteries, the arteries tend to have a smaller lumen and much more muscle to help control and help the heart pump the blood around the body, because these arteries can contract and send blood all around the body or into the lungs. Veins have a much larger lumen, which means the opening in the center of a vein or artery that carries the blood. The veins can act as a storage place for the blood, and that's because they're much bigger, they're irregular in shape, and they have a much thinner wall with muscle in it. So the structure of the artery and the vein indicates the function of receiving the blood, stretching and with an elastic stretch, and then coming back, helping the blood be pumped from muscle activity, and the fact that the arteries have a good bit of elastic tissue, which can be stretched and then recoil. The veins have a large lumen and they're irregular shaped. That's because they just have to store and transport the blood that is at much lower pressure. Here's another comparison of the blood vessels, vein versus artery. So you should know that there are elastic arteries, muscular arteries, and arterioles. And then there's a large vein, medium, and a venule. So the arterioles send blood to capillaries. The venules pick up that blood at the other end of the capillary. An elastic artery is very, very important, and it's the first arteries that leave the heart, because when the heart pumps into the aorta, for instance, these elastic connective tissue, these elastic tissue causes the artery to expand very quickly, and then it recoils back. So it's actually helping the heart push the blood around the body, because the elastic stretching and then recoil to help pump the blood by its recoil, where the lumen of the artery becomes much smaller. And when that happens, the blood that has been pumped from the heart is pumped again, so to speak, by the artery. If you look at the capillary bed, this is called the arterial side, and sphincters, little gatekeeping muscle. The sphincters control which capillaries receive blood and which don't. So you know that if you're eating, your blood flow to your muscle capillaries is going to be shut off, and much more blood is sent into the digestive capillaries. Once you digest your food, you'll have the opposite situation, where the capillaries of the muscles receive a large amount of blood, because the muscles have to contract and allow you to respond to work or danger or to run and so on. So these sphincters are constant gatekeepers, depending upon whether you're eating or running, control the blood flow into capillary systems, and it may block the entire capillary bed So for instance, when you're running, you're going to have blood blocked off from the blood vessels of the digestive system, and you're going to have blood sent to the muscles. Okay, so this is a repeat of the capillary bed. The arterial vessel goes into the capillary bed, and so it goes from small artery to arterial into the capillary beds. And on the other side of the capillary beds, a venule will pick up the blood to start the blood on its way through the veins to be returned to the heart. Okay, the muscles, as muscles contract, the veins are compressed. So muscle contraction and the heart, the venous valves help make sure blood gets back to the heart by preventing backflow and by responding to muscle contraction. Okay, let's stop here, stop the recording and keep going.